Hello guys, so in the last video we learned how to solve a cubic equation by factoring, and all of those cubic equations were made up by four terms. So we learned how to group the first two terms to the last two terms. We found the greatest common factor, and then we always end up to solve two different equations. One was a linear equation, the other one was a quadratic equation, sometimes with real solutions, sometimes with imaginary solutions. And we always found that there were three possible solutions. So we're still gonna keep practicing on solving cubic equation, but in this case I'm gonna show you some examples in which instead of having four terms, we actually can have equation with only two terms. Okay? Alright. So here is the first example. Imagine we have x cubed minus 125 equals 0. Okay. Now, how would you solve this? Well, the temptation may be to try to get x cubed by itself and then take the cubic root on both sides and be done with that. But actually, that's not really is not the right approach, because you may end up with a single solution from that strategy when instead there are three possible solutions. Okay, so you may be tempted to do something like this: add the 125 on both sides, take the cubic root, right? Then we get x by itself, right? And you say, well, cubic root of 125 is 5, because 5 times 5 times 5, 3 times is 125, and actually work, right? So we know that 5 is the solution, because 5 cubed is 125. 125 minus 125 is equal to 0. So, and you say, well, we are done with this. But this is not the right approach of solving a cubic equation of this form. Again, the reason is that there are three solutions. So there is another strategy we should use instead. And this is what I'm going to show you. And the strategy I'm going to show you is to use the formula for the difference of cube. This x cubed minus 125 represent a difference of cube. Okay? So let me write down here on the right hand side the difference of cube formula. Okay, and then here I'm gonna write the sum. Actually, let me move this a little bit. And then here I'm gonna also write the sum of cubes formula. And this is what we're going to use. Okay, so difference of cube formula is this. If I have the difference of two cubes, a cube minus b cube, this can be written as a minus b times a squared plus ab plus b squared. Sum of cube formula is very similar. Instead of a negative sign, we're going to have a positive sign. So is a cube plus b cube equal to a plus b times a square minus ab plus b squared. Okay, so difference of cube, we have a minus here, we have a minus here between a and b, but then everything else in parentheses is positive. For the sum of cube formula, we have a positive here in the first parenthesis, but there is a minus with the ab. So we're going to use this formula to solve this type of cubic equation. Now, how are we going to proceed? Take a look at the two formulas. Which one do you think is represented by the amount we have on the left hand side of this equation? We have x cubed minus 125. So do you think we're going to use the difference formula, or do you think we're going to use the sum of cube formula? Well, it looks clear that you should use the difference formula, because there is a minus, right? There is an x cubed minus 125. So what it means is that we have the left hand side of this formula. So we have this piece. This is given to us, a cube minus b cube, which is x cubed is the same of a cube, and 125 is the same of b cube, right? So based on the formula, now what we need to have, so let me write down the formula, is a minus b times a squared plus ab plus b squared. So the only thing we need to do is find the value of a and b, and we're going to do this by comparison, okay? So I know by comparison that a cubed is the same thing of x cubed, right? These two are the same. And I know by comparison that 125 is the same thing of b cubed. So based on this one, can we figure out what's a and what's b? Okay, let's do this on the side. What's a and what's b? So I know that a cube is the same of x cubed. So what do you think is a? Well, a must be equal to x, right? Because a square is going to be the same of x squared, and a cube is going to be the same of x cubed, right? A cube means to multiply a by itself 3 times. So x times x times x 3 times makes x cubed. If b cubed is the same of 125, how do we find the value of b? Well, I need to find the number that multiplied by itself 3 times is going to give me 125. What do you think is this number? And if you cannot find this number, start from 1, then move to 2, move to 3, and so on. Like if you start from 1, you get 1 times 1 times 1, which is 1, so you know it's not going to work. We need to get 125. 2 times 2 times 2, which is 8, it's not going to work. 3 times 3 times 3, which is 27, it's not going to work. 4 times 4 times 4 is 64, it's not going to work. And then you end up with 5 times 5 times 5, which is 25 times 5 or equal to 125. So this number is 5. Okay? Once you find a and b, the only thing you need to do is plug it in into this formula. So what's a minus b? Well, a minus b becomes x minus 5, so now I plug it in, right? And then a squared is the square of x, which is x squared. ab is the product of these two, which is 5x. And b squared is the square of 5, which is 25. So now we're going to set up this equal to 0, and we're going to solve it. So this is the product of two numbers, two terms is equal to 0 when either x minus 5 is equal to 0, or when x squared plus 5x plus 25 is equal to 0. First one is very simple to solve, so it just gives us x equals 0. The second one we cannot factor, okay? We cannot factor. And therefore, we need to use the quadratic formula, which I remind you is negative b, opposite of b, plus minus square root of b squared minus 4ac divided by 2a. Alright, so, but now I need to look only at this one, okay? So, negative b becomes negative 5 plus minus square root of 25 minus 4 times ac means 25 times 4 because a is equal 1. So that would be 200, and then divide this by 2a, which is 2. So we get negative 5 plus and minus, so square root of negative 175. And then we're going to divide this by 2 times a, which is 2. So now let's see if we can simplify this. The negative becomes I. So we get negative 5 plus minus I. So 175 is going to be 2. Let me see if we can simplify this. It will be 175 divided by 5. This should be 7, right? Let me see. 175, if we divide by 5. Sorry, if we divide by 25, not by 5. So if we divide by 25, let's see, 7 times 5 would be 35, and then 7 times 2 would be 14, yes. Okay, so it's 25, so that would be square root of 25 times 5, right? And then divide by 2, so this becomes negative 5 plus and minus. We know square root of 25 is 5, so it becomes 5 square root of 5 and then divide by 2. Okay? Okay, oh, I forgot the I, of course. There is an I here. Okay, so what's the solution set? So the solution set is, we found 5, which is one solution, and then we have negative 5 minus I, 5 square root of 5 divided by 2, and the other solution is negative 5 plus I 5 square root of 5 and then divided by 2. You see there are many more steps actually, solving a cubic equation with only 2 terms than when we had to solve with 4 terms, okay? And this is because of these quadratic equations here that we can actually factor and it give you imaginary solutions. But anyway, I'm going to show you some other examples. Alright, so let me try with this one. X cubed minus 64 equal to 0. Alright, so remember the 2 formulas. So we're going to use the formula for the difference again, which is a cubed minus b cubed equal to a minus b times a square plus ab plus b squared. And so the goal again is to find a and b. We know that you should try to do this by yourself, by the way, okay? And then check with me. So we know a cube is the same of x cubed, and we know that the b cube is the same of 64. So what do you think is a and b? Well, if a cube is x cubed, then a must be equal to x, and then b, which number multiplied by itself 3 times is going to give you 64? That is going to be 4. So now we plug it in into the right hand side. A minus b, here we have x cubed minus 64, right? So a minus b will be x minus 4 times the square of a, which is x squared, plus ab, which is 4x, plus b squared, which is 16, and we set up this equal to 0. So the solutions are given by x minus 4 equals 0, or x squared plus 4x plus 16 equals 0. The first one is again simple to solve, x equals 4. The second one, we're going to use the quadratic formula, which is negative b plus minus square root of b squared minus 4ac divided by 2a, which translates in this case to the opposite of b, which is negative 4 plus and minus b squared is 16 minus 4ac becomes 4 times 16, which is 64, and then all of these divided by 2 times a, which is 2. So we get negative 4 plus and minus 16 minus 64 will be square root of negative 48 divided by 2. Now the square root of 48 I can write as a square root of 16 times 3. We know the square root of 16 is 4, so this is the same of 4 square root of 3, and therefore this becomes negative 4 plus minus, let me rewrite this, so negative 4 plus minus I, square root of 16 is, we said is 4, so it's 4 square root of 3 and then divided by 2. And then we can simplify dividing everything by 2, so we get negative 2 plus minus I 4 divided by 2 is 2 square root of 3. So the solution set is 4 and then negative 2 minus 2i, or I2 is the same thing, square root of 3, and then negative 2 plus 2i square root of 3. Okay, let me show you one last example with, let's see if I can find one with the sum. Okay, let's do this. X cubed plus 8 equals 0. Okay, so try to do this by yourself. Now the formula we're going to use is, in this case, a cubed plus b cubed equal to a plus b times a square minus ab plus b squared. So what's a, what's b? Well, I know that x cubed is the same of a cube. I know that b cubed is the same of 8. So I know that a is equal to x, and b, well, which number multiplied by itself 3 times give me 8? There will be 2. So here on the left side I have x cubed plus 8. On the right hand side, a plus b will be x plus 2 times a squared, which is x squared, minus ab becomes minus 2x, and then plus b squared, which is 4, equal to 0. So, to find the solution, we set up x plus 2 equal to 0, or x squared minus 2x plus 4 equal to 0. From the first one, we just get x equal negative 2, and for the second one, again, we're going to use the quadratic formula. I'm not going to rewrite the quadratic formula. You should have it with you. So it's minus b, which is 2, plus and minus, square root of b squared, it's a plus, okay? Square root of b squared, which is 4, minus 4 times ac, which in this case is 16, divided by 2. So it's 2 plus and minus 4 minus 16 is the square root of negative 12 divided by 2, so it's 2 plus and minus. Now square root of 12 is the square root of 4 times square root of 3, and square root of 4 is 2, so that's I 2 square root of 3. The I comes from the negative sign, and then divide by 2. If we divide everything by 2, we get 1 plus and minus. 2 divided by 2 is 1, so I square root of 3. So the solution set is negative 2, 1 minus I square root of 3, and then 1 plus I square root of 3. Okay? Alright, so I'm gonna assign you one last problem, and then I also give you the solution so you can check if this is correct. Actually, I'm gonna assign you two different problems. Alright, so the first one is x cubed. So instead of plus 8, try to do x cubed minus 8 equal to 0. Okay, try to work this by yourself. And then I give you one a little bit more challenging, which is this one, 27 x cubed plus 64 equal to 0. Okay? Alright, so from the first one, the solution you should find, well, actually don't have the solution for this, but I guess I'm gonna, let me see, I can work it for you. Oh, I don't have the solution for both of them. Okay, let me do this. Let me work them out quickly, but please again try to do this problem by yourself. Okay. Alright, so for the first one, I'm gonna use the difference of cube formula. So we have that a. So a will be equal to x, and then b will be equal to 2. So from the formula we get that x cubed minus 8. So if you remember the formula, I'm going to write here, which is a plus b. So a minus b times a squared minus ab plus b squared, which in this case becomes x minus 2, times x squared plus ab, which is 2x plus 4, and then equal to 0. And then from here you get, well, one solution is clearly x equal to 2, and then for the other one you use the quadratic formula, which is a negative 2 plus and minus the square root of 4 minus 16 divided by 2. So this is going to be negative 2 plus and minus. This becomes square root of negative 12. So I'm going to do this quickly because it's very similar to what we did previously. That's the square root of negative 12, which is simplified into 4 times 3, which is 2 square root of 3. So I 2 square root of 3 divided by 2. So the solution set for problem number 1 is 2. And then if you divide everything by 2, you get negative 1 minus I square root of 3, and then negative 1 plus I square root of 3. Okay? Alright, and then for problem number 2, which I was saying is a little bit more challenging, again, please try to do this by yourself, but we have that the formula we're going to use is a cubed plus b cubed equal to a plus b times a squared minus ab plus b squared, where a, well, we know that a cube is 27x cubed, and we know that b cubed is equal to 64. So from here I have the a, well, which number multiplied by itself 3 times give me 27? That will be 3. And since I have x cubed, this is going to become x, so a is equal to 3x. And then for the b part, we have that this quantity is equal to 4. So let's plug it in. We get a plus b, which is 3x plus 4, times a square, which now becomes 9x squared because it's 3x times 3x, minus ab, which is 12x, and then plus b squared, which is 16, equal to 0. So the equation we need to solve are 3x plus 4 equals 0, and then for the second one is 9x squared minus 12x plus 16 equal to 0. So from the first one, we get a negative 4/3, and then for the second one, using the quadratic formula, we get the opposite of b, which is 12, plus and minus the square root of b squared, which is 144, minus 4 times AC, which is 9 times 16 times 4. Okay? Alright, so let me use my calculator so I can make sure that I do this correctly. So we need to multiply 4 times 16 times 9. So this is going to give me negative 576. And then all of these divide by 2a, which is 18. And then 144 minus 576 is equal to negative 432. So we get 12 plus and minus negative 432, and then divide by 18. And at this point, we probably can simplify this negative 432. Let me see if it is divisible by 16. Yes, it's actually divisible by 16, so what we get is 12 plus and minus. So I can break this down as negative square root of 16 times the square root of 27 and divisible, and then divide by 18. So this becomes 12 plus and minus the negative becomes I, square root of 16 is 4, and then we're going to keep a square root of 27 all divided by 18. Notice how everything is divisible by 2, so 12 divided by 2 is 6, and then this becomes 2I square root of 27, and then all divided by 18 divided by 2, remember we divide everything by 2 is 9. So the solution set for these problems is negative 4/3, and then we have, by the way, we can still simplify this because we have a square root of 27, which I can write as 9 times 3. So let me complete this, okay? So at this point I just completed, so is 2I, so square root of 27 is 9 times 3, which is 3 square root of 3, and then divide by 9, so I can divide now everything by 3. So 6 divided by 3 is 2, plus and minus, this becomes 2I square root of 3, I'm dividing this by 3, so the 3 goes away, and then 9 divided by 3 is 3, okay? So the solution is negative 4/3, and then 2 minus 2I square root of 3 over 3, and then 2 plus 2I square root of 3 divided by 3. Okay, so I went a little bit fast in this video showing you all these problems, but of course, you are more than welcome to stop the video, to work this problem slowly. Okay, I know it's lots of steps. Okay, even though there are only 2 terms, it's a little bit more tedious than the one with the 4 terms where we can factor 2 by 2. But again, you need to be able to use this formula for the sum of cubes or for the difference of cubes. And I believe that the main challenge is to identify the values of a and b, and then all the times notice how we use the quadratic formula using also complex numbers. And this complex number comes from the fact that we always end up with the square root of a negative number. But anyway, this can be quite challenging. Okay, let me know if you have questions. Okay, and again, for the these last few videos, we're gonna just focus on solving equations, and this can be very useful, especially if next year you're going to register. You're going to attend the pre-calculus class.